Hello everyone. Today we'll make a quick video about commissioning and startup of ACS 800 drive from ABB. So this is one of the most famous and the most reliable drive from ABB. So we will see how we can commission the ACS 800 drive for a quick startup. Okay. So this is the setup I have got. So there are 3 slots on the drive. So I have used slot 1 for the field bus card, which is the RPBA card, which is the Profibus communication card, and the second slot I have used for RTAC01, which is the encoder card, and the third slot is RDCO, which is the fiber converter for communicating with the drive, for programming the drive or parameterization using RUSB from your PC, and this is the card used for that. The you can connect 2 fibers over this channel 3, and the other side you can connect to your RUSB device, which is the USB device, and you can connect to your PC. Okay, so um, so this is the setup I have done. So this is the analog input. So I have an analog input here, and this is analog input 2, which I am not using. This is analog output, which again I am not using, and these are the digital inputs, and this is the external 24 volt, and this is the 3 1 2 3 relay outputs, and uh, always make sure this connection is done. If if you don't have a jumper or a wire connected from 8 to 11, this will definitely trip on start interlock. And if you have some circuit in between, you can connect all those, like an e-stop or something, you can connect in between this. Or if you don't have anything, just put a wire across 8 to 11. Okay, now we will open the software. So you can use either drive window or drive composer, both will work. So I will use drive window. Okay, when you open drive window, the default setting, this one, you can keep this if you are using the RUSB. I'm using RUSB. So when you click OK, it will search for the drive, and here you have. Okay, so open this parameters. What I will do right now is I will restore all the parameter. That is, I will put the drive to the factory, like a factory reset. So you can click here, yes, it's okay. So what it does is, like, it put back all the parameters like default parameters. So I will just refresh the parameters. Okay, okay, so we'll start with 99th group, which is the most important group of the drive, because here is where you enter the motor details. Okay, so this is the motor I have got. So I have a 400 volt motor, 50 hertz, 3 kilowatt, 1430 rpm, 6.25 amps. Okay, I'll enter all this here. So 400 volt, 6.25 amps, 50 hertz, 1430 rpm, kilowatt is 3 kilowatt. Okay, so now the 99th group is done. Now now normally we go to the limits, but I will start explaining from first. Okay, As you can see this, you have the parameter group number 1, 2, 3, 4, 9. These are the actual signals, means these are the signals that you can read from the drive for your application. Like if you have a PLC connected using Profibus, you can access all these values to use it for your program, or you can use this for troubleshooting to plot the trend or graph, etc. Okay, so the 10th group, which is the start stop direction. So here is where you define how you are going to start and stop the drive. So before that, you have something called as application macro here. So here you can see so many macros available. Macros are nothing but some predefined parameters for easy commissioning. So if you select factory, which will automatically gives this parameter settings, which means DI1 gives the start command and DI2 defines which direction the motor should run. So if you have an application where you have to run the motor forward and reverse, what you can do is you need to change this to request. As per the request, the motor changes the direction. If you keep it forward, the motor will only run it in forward direction. And let's say if you have a field bus, then you will have option to give by command word. Okay, so now let's keep it at DA1, DA2, and reference select how you are going to give the speed reference. So here you have two options to give external 1 and external 2. So if I put external 1, the reference comes from here. So this now the reference is coming from the analog input 1. You can change according to your requirement. And constant speed is like you can define certain digital inputs, and you can define how when each digital input switches, which speed you can select. You have the option to give almost 15 speed. Okay, so you can define so many inputs here. Like you have the option like even you can define 3 DI3, DI4, DI5, DI6. If you define this according to each input, you can define how many which speed the drive should run. Okay, and analog inputs. So here you can define the scale. You can like the 4 to 20 or 0 to 10 volt analog input, you can multiply with the scale factor, and you can define your own analog input and give it back as a speed reference. And the relay output. So as I shown you. So I'm going to use this relay output one for the brake, because I have a brake on the motor. So I have a brake which is coupled on the back side of the motor, so I have to use this brake control. Okay, so the analog output, like if you have a ammeter, or like you want to show the RPM on a physical meter, you can use this. And you can define like run enable. Normally we keep it at yes, or you can define an input which gives a like an interlock or something. And passcode, like if you enter the passcode, some hidden parameters will be opened like this. I have already entered the password. So if you if you don't enter, normally your parameters will show up to 99 only. Okay, and the fault reset, like how you are going to reset the fault. You can define a digital input to reset, or from if you are using PLC, you can use this. And user macro IO changes, like you can define, like for example, this one drive is used to control 2 motors, so you will have 2 parameter groups. So that you can define here. I think that needs time to explain more. Today I'll just go to this. So in the limits, here is another very important parameter. Here is where you'll put the limits for the motor. So my motor is maximum RPM is 1430. So I put you can define rated RPM, or you can use this. But once you go above the rated RPM, your rated torque will come down. Okay, and your maximum current. So my motor current is 6.25. Normally we keep 150% of the motor current. So let's define 9 amps. And the torque limit, you can, since you defined 150% of motor current, means I can only get a torque up to 150%. So voltage control, you can keep it on, but if you have a brake chopper, you need to keep this off. Okay. So now we'll go to start stop function. Like auto means the drive decides how the motor should work before getting, like after getting a start command, how the motor should magnetize. I used to keep it at constant DC magnetization, where I can define the magnetizing time for magnetizing the motor. Let's say you have a big motor, or this depends on the size of the motor. The more kilowatt motor will require more time to magnetize. So you can define that here. And the stop function, you can, I'll keep it as a ramp. And the acceleration deceleration, let's say I'm going to use this. I will select acceleration deceleration 1. I'll put how much time you want. Let's say I put 5 seconds. Then speed control, you can define the gain, integral, derivatives time. Normally we keep it default. If you find that your speed reference and actual speed is not matching, you can play with it. This is not important. Now brake chopper. As I said, if you have brake chopper, you need to keep this on, and you need to keep all voltage controllers off. So what it does is that normally when you have a regenerative function, like when your motor decelerate, or for hoist application, basically when you are lowering, there is always a regenerative voltage going back to the drive. So what it does is that it increases the DC bus voltage level. So whenever the DC bus voltage go above a certain value, the brake chopper will keep it on, and that extra voltage will get dropped in the external resistor bank connected. Okay. So if you have a resistor bank, you will find the name details. You can find how much ohms and how much it's the kilowatt rating, and you can define that here. This is basically to generate the brake chopper fault. That's why we enter the value here. Okay, so I don't have a brake chopper, so I keep it off. And fault functions, if you have an external fault, you can define which input is the external fault. And you have some options, like if you have a panel loss, should it trip, or a lot of options you can find. Okay, and here you have a motor temperature measurement. When you use a DTC, the drive can use these parameters to make a motor temperature assumption. Okay, now I'll go to the important parameters. Yeah, brake control. So if you have a brake on the motor, you can use this, keep it on. And acknowledgement, like the brake contactor acknowledgement, if you have, you can define the input for that. Since I don't have, I keep it off. And I can define how much is the brake open time delay. Let's say 1 second, 1 second. And this is another important parameter, like this speed, like now I put 10. So whenever your motor reaches 10 rpm, the drive detect it as a zero speed level and close the brake. And brake fault function, you can keep it fault or warning. Normally, since brake is an important device, we keep it as a fault. And this is again, this is a useful parameter when your application is, let's say you're going to hoist something, you can keep this as 42.8. means here you can define, let's say I put 10. This means that the brake will open once the motor magnetize and make a the motor reaches 10% torque, then only the brake will open. This makes sure like a safety feature. So if you require, you do this, or you can keep it as no. And these are depends on your site requirement. And optional module. So if you have encoder module, you can define this. So I have an encoder module in slot 2, but I'm not going to define because I don't have an encoder on the motor. So if you have encoder module, you can define that. And communication module, if you have, you can define. I have a field bus module, so I can define this. And you can see there is no field bus parameters here. What you have to do is you need to refresh this parameter once you select that field bus. Okay, see, now the new parameters have opened. So here you can define what is the field bus that you are going to use. Then this I will cover up in the next video. And okay, now we are good to start the drive. Okay, so here you can see there are two modes, that is a DTC and scalar. DTC is a direct torque control. So this is the suggested mode to run the motor, because this gives a maximum performance, and you can as the name suggests, you can control the torque directly. And scalar mode is again useful just to do the initial starting of the motor before doing an ID run. Let's say before doing an ID run, you need to make sure the motor works fine. So you can utilize this, and you can give a start command. So let's say I'm going to give a start command, and I will plot some trend. So this is the trend setting. So you can define what is the interval required and how much seconds it need to plot. And you can define some scale. And let's say I want to plot this motor current, then speed, then what, output voltage, frequency. So I can plot up to 6. I'll plot the torque as well. Okay, now we'll give a, so when you click play, it start plotting. We'll give a start command. So in order to do this software to give the local control, you need to press this. So you can see the commands opening, and you can define what speed the motor should run. Sorry. So when your motor is running in scalar mode, you can only give frequency. Like you cannot input how much RPM the motor can run. You can only define the frequency. Let's say I run this motor in 20 frequency. Okay, so now the motor is in 20. If I give a start command, the motor will run. I give the start command. what happened was this graph went outside the limit. So what we can do is can give the coefficient as 0.1, 0.1, okay. So you can see the motor current, then output voltage, then frequency, this is the motor frequency, and this is the RPM. Okay, so now what we can do is we can put this drive to DTC mode. So I'll stop all this. So now we made sure the motor runs freely. Okay, so when before doing the DTC mode, we need to make sure the motor is fully free to rotate. So what I'll do is I'll keep this relay always high, means my brake should be always open. So I'll put it to, you can use anything, I use this, so this will make sure the relay is always high. And you can always see this relay status over here. Yeah, you can see the relay 1 is high. Okay, if you are wondering how I got this yellow color, this is this means it is always online. What you can do is the preferences, you can activate this one, just make sure all the parameters are online. Okay, so now we are going to do the ID run for the motor. So before doing the ID run, always make sure the limits are completely open. So you need to go out of this, refresh the parameters, and click check the limits. So my speed is okay, my current is above the limit, torque is fine. So there is nothing that limits the motor in the ID run. Okay, now it is safe to run the motor in DTC. So you always make sure the motor is completely free to rotate, and also you have different ID run option. So once you put it back to DTC, you can you can immediately see the drive went to warning. Okay, so you click false, you can see that there is a warning, that is ID magnetization required. So you can go back to 99, you can define how you are going to perform the ID run. So the maximum performance of the motor is achieved when you do the ID run in standard. Okay, so ID magnetization means it is like a stationary measurement where you measure only the cable resistance, motor resistance, inductance, etc. So when you do the standard ID run, it does everything like speed tuning, including stationary measurement, etc. So now if I give a start command, the motor is going to perform the ID run. So always make sure the motor is completely free. I normally rotate the motor by hand to make sure the motor is completely free. So now if I give a start command, the motor is going to run. So let's give. So the ID run has started. Now it's doing the stationary measurement like cable resistance, etc. It just gives a small voltage to measure the resistance of the coil. Okay, I didn't select standard. Okay, wait. Okay, So I want to perform this ID run again. Now the ID run is getting performed in standard mode. You can see the motor jumps up and down the speed. So this is what happening during the ID run to the motor. Okay, so ID run is done. ID run done. So if you have a problem during ID run, normally it trips with ID run failed. So now ID run done means my ID run is finished. So you can see the graph. What I will do is put it 500. Okay. So you can see how much speed the motor run. The motor run in full speed. Okay. So it ran in 1252 RPM. So this, now make sure your ID run is done. Now you can give the speed in RPM. So let's say I keep 500 RPM. So you can see my speed reach 500 RPM. I can define 1500 as well. I can reverse the motor. This is exact ramp time, 5 seconds I have given, and you can stop. So this is how we do a quick commissioning, ID run, and basic startup of the motor. So I hope this was clear to everyone. So thanks for watching this video. Have a great day. Thank you.